GATE 2019 Civil Engineering Set 1 Question 36. A 16 mm thick gusset plate is connected to the 12 mm thick flange plate of an I section using fillet welds on both sides as shown in the figure. The gusset plate is subjected to a point load of 350 kN acting at a distance of 100 mm from the flange plate. Size of fillet weld is 10 mm. The maximum resultant stress in megapascal round off to 1 decimal place on the fillet weld along the vertical plane would be. Reference to the relevant NPTEL courses or video has been cited. Now coming to the useful data, here we will be discussing about welded eccentric connection. Let's say a load P is acting at some distance E from the flange plate and the size of the weld is H, let's say, and we can say the thickness of the flange is T. So the load is acting perpendicular to the plane of welding, which will be perpendicular to our screen. So let's say if we replace the load which will acted here, we will see some amount of moment here, that will be P into E here, due to the load and moment there will be two stresses will be acting here. The first stress due to load will be direct shear stress, and due to moment the stress acting here will be bending stress. But in case of bolted connection we avoid the bending stress. Now the direct shear stress will be load upon area. Let's say the load is P, the total area will be 2T into H. So we can write here 2H into T. So our direct shear stress will be P by 2HT. This will be our first equation. This is direct shear stress, so we can write it Q as well. Now coming to the second stress, bending stress, that will be M upon Z, where Z is section modulus. Moment here is P into E, and for section modulus we are considering the welded connection as a rectangular, so it will be BD square by 6. Here B is 2T and D is H here, so it will be H square by 6, so it will be TH square by 3. So if we simplify it, it will be 3PE divided by T into H square. This will be our second equation. As per our code, the resultant stress Fe will be, if direct shear stress is Q and bending stress is F, we can write resultant stress Fe equals to F square plus 3Q square, which should be less than the permissible limit, which is Fu upon root 3 into gamma mw. Now coming to the video solution, the load here is P equals to 350 kilonewton, E is 100 mm, float thickness TT equals to 0.7 into size of weld given is 10 mm, so it will be 7 mm. Now the first thing, shear stress due to direct force or direct shear stress will be P upon 2H into T. So P is 350 into 10 the power 3 divided by 2 into H given is 500 in mm into T is 7. So when we solve it, the direct shear stress Q we are getting is 50 Newton per mm square. Now shear stress due to moment will be bearing stress F, that will be M upon Z, moment upon section modulus, that will be 3PE upon T into H square. 3 into 350 into 10 the power 3 divided by 7 into 500 square, that will be 16 Newton per mm square. Resultant stress Fr will be under root F square plus 3Q square, which should be less than resistance of weld or shear strength of the weld, that is Fu upon root 3 into gamma mw. Let's say if this is a sock weld, this will be 410 upon root 3 into 1.25, that will be 189.37 Newton per mm square. Now the resultant stress will be under root 60 square plus 3 into 50 square, which will be 105.36 Newton per mm square, which is less than 189.37 Newton per mm square, which is same. The maximum resultant stress on the fillet weld along the vertical plane would be 105.36 Newton per mm square. Reference to the relevant NPTEL courses or video has been cited.